Yes, so shall we start? So yes, uh, let's do one example initially. The four variable came in. Till now, we only discussed the SOP. So sigma m 0, 1, 3, 4, 7, 8, 10, 12, 13, 14, and okay. So that is the F, A, comma B, comma C, comma D. That's some change in that. No? I'm using that F, D, comma C, comma B. Okay, ABCD is easy, so we can try the D, C, B, and A. That means D is MSB and A is LSB. Now I want to represent it as the ABCD 0001 1110 0001 11 and 10. Now this is the 0. This is what? D 1 C 0 B 0 and A 0. So that means the number is 8. Okay. For this one D 1 C 0 B 1 A 0 10 D 1 0 1 1 11 and this one 1 0 0 1 9. Similarly for this one 0 0 1 0 2 0 0 1 1 3 0 0 0 1 1. Okay. This one 1 1 0 0 12. This one 1 1 1 0 14. This one 1 1 1 1 15. This one 1 1 0 1 20. This one 0 1 0 0 4. 01106 01117 and remaining is 0101. Okay. Any doubt in this numbering representation, number representation? Any doubt?
No, sir.
Now where the mean terms present? 0, so I can represent it 1, this one, 3, 4, 7, 8, 10, 12, 13, 14, 15. Now group. One is the group of 4. This one. One is the group of 4. This one. One is the group of 4. This one. Then group of 2 and okay. So 3 group of 4 and 2 group of 2. Now can you write a expression for that one? So for this group of 4, the A and B is the constant. A bar, B bar. Plus for this column group, C and D is the constant. C and plus for the group of 4, A is constant and D is constant. So the value of D is 1 and value of A is 0. So D is C. Plus for the group of 2, this one, the A is constant, C and D is constant. C bar, B bar, A. And for this group, AB is constant and C is constant. So C, B, A.
Sir, can we also write it as on the top where we have written A, B, C, D?
Yeah, you can write that
You
one.
can
You can write that one. No
we
issue.
can write C, D, B, A, and then do it.
Yeah, we can create in this form also. E, C,
B, A, right?
C, 0 0 0 1 1 1 0 0 1 1 0. Okay, the number is 0 1 3 2 4 5 7 6 8 9 11 10 12 13 15 14. Okay, if I want to create a particular term, so this one, this 7, 8, 10, 12, 13, 14. Okay, so again the group is this one.
Yes, sir.
One group is this one. Then group of these two and these two. This one. And you can create this group or any group. Okay,
Yes,
over
sir.
this one. So if we write a equation for this one, this group is there, that is again a bar b bar plus, if you write a expression for this row, so that is cd dc. Okay, if I write a group of this 2 1 2 4, so d is constant and b a is constant, so a bar. Okay, plus if you create a expression for this one, so c bar d bar, and a is 1, so a, plus for this group d is constant, so d bar ab. Okay, or
Okay, sir.
so if you see that all terms are same, 1 2 3 4 terms are same, only this term is different. Okay, and similar way that if you create in place of this group, okay, in place of this one, if you create this group, because this one is pending now, this one will be
Yes, sir.
created a group of upper one and as well as the lower one.
Yes, sir.
Okay, so for the lower one the value is c a and b, c a b. So either this term is available or this term is available.
Okay, sir.
Okay, similar to here is if you create a group with this one, so this cba term is present. If you create a group of this and this row side, so the group is a b because row, and d is constant, d is 0, so d bar this term and this term. Okay, so any method you can use.
Okay, sir. So, sir, if multiple answers are available, we just have to check what
You
is
have to
given.
check, yeah,
What
we
is
have to check all
okay?
the answers.
Okay, sir.
Okay, in the one option this is also given, in the second option this is also given. So this type of question will be generally, basically gate examination will be do this type of question. Why? Because in the hurry up what we do, we are only check this answer, okay, and tick that one. But this is the multi-select question, so there is a one option of this one, there is a one option also, a v bar plus dc plus d a bar plus d bar c bar a plus a b d bar. So directly what we do, we are doing either checking this one or checking this one.
Right, right, sir.
Okay, so this type of question will be asking in the gate examination, multi-select questions.
Okay, okay, sir.
Okay, now again if we want to verify that the answer is correct, so what we do, we have to convert into the standard canonical form. So if I want to connect this, convert it to the assistant canonical form, so A bar, B bar, C and D is missing, so I just multiply with C plus C bar and D plus D bar. Plus in this term, D C D is available, I just multiply with A plus A bar, B plus. Here A bar D is available, I just multiply B plus B bar, C plus C bar. Here B bar is missing, so D bar, C bar, A, B plus B bar. And C is missing, so A, B, C plus C bar, D bar. Okay. So from that one, the first term is the A bar, B bar. Now we have a CD, CD bar, C bar D and C bar D bar. So I just directly multiply A, B, C, D, A bar, B bar, C, D bar, A bar, B bar, C bar D, so plus A bar, B bar, C bar D, plus here if we check that A, B, C, D, plus A, B bar, C, D, plus A bar, B, C, D, plus A bar, B bar. Now if you check that A bar, B bar, C, D, that is also available, so I am not writing that. Okay. So 4 terms from here. From this one, 4 terms, but 3 unique terms and 1 repeat term. That's why 3 terms. Okay. Now if we check this one, so A bar, B, C, D. A bar, B, C, D already available. A bar, so I just write A bar, B, C, D, A bar, B bar, C, D, A, B bar, A bar, B, C bar, D, and A bar, B bar, C bar. Okay, BC, B bar C, BC bar, and B bar C. Okay, plus A, B, C bar, D bar, plus A, B bar, C bar, D bar. 2 terms from here. Okay, and from this one 2 terms. A, B, C, D bar, plus A, B, C bar, D bar. Okay, so 2 terms, 4, 4, and 4. If I just represent with the binary number 0, 0, sorry, just remember that this is a DCBA, okay, because the MSB is D. So 1, 1, 0, 0, 12, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1. This one is 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, sorry, 1, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1. So this is a 12, 8, sorry, 4, 8, 0, 15, 13, 14, 12 already, so we discard this term. 14 already, we discard this term. 12 already, discard this term. 10, 8 already, discard this term. 3, 1, 7, 3 already, discard this term. So this is a 0, 1, 3, 4, 7, 8, 10, 12, 13, 14, and 15. Sigma. Now match this one is equal to this one. 0, 1, 3, 4, 7, 8, 10, 12, 13. Okay.
Yes, sir.
Now the POS. Okay. Like for example, pi m 0, 1, 4, and 7. I just take in the three variables initially. A, B, C. So the POS KMAP will be solved in two methods. Either one thing is that we can solve in the POS form, or we can solve into the okay. So what is the meaning of POS form and what is the meaning of SOP form? That if I want to show this one in the POS form, so this is a three variable, 8 terms are there. So I just take A 0, 0, 0, 1, 1, 1, 1, 0. Okay. Now POS term will be defined for logic 0. Okay, we already discussed that one. POS term will be defined for the logic 0. So for POS term defined for the logic 0. So one way is that we can put 0, 0, so 0, 1, 3, 2, 4, 5, 7. Okay. Now create a group. One group with this one group with this one, and this one is we can't create a group for this one, so it is a single. Okay. Now for the this group, A is constant as well as B is constant. Okay. A and B both have a constant. So I can represent this one in terms of POS. So how the POS term will be defined? Every term will be the summation. Okay, like if I say that this one A is constant, so what is the value of A is simply A plus the B is on constant and the value is 0, so A plus B. Why I just write A plus B? because in the SOP 0 represent the A bar and 1 represent the A. In the case of POS, 0 represent with the A or variable and 1 represent the variable bar. Okay.
Yes.
So for this group, A is constant, that is 0, and B is also constant 0. So I just write A plus B because it is a POS form. For this column, B and C is constant. So the next term is B plus C. Because the value is 0 for both, so I just write B plus C. And for the third, this single group, A is constant 1, B and C is constant 1. So the term is A bar plus B bar plus. Okay.
Yes, sir.
This is the POS form. Second method is the SOP form. So we convert into the SOP. So which term are defined in the POS that are not defined in the SOP. So sigma m 2, 3, 5 and 6. So 0, 0, 0, 1, 1, 1, 0, 0 and 1. Okay. Now for the 2, for the 3, for 5 and 6. Okay. Where POS terms are not defined, that is defined in SOP. Now again the group is one group with this one group with this one, and one simple group. So for this row group, the value is A is 0, so A bar. The value of B is 1, so A bar plus. For the column group, A is not constant, but B and C is constant. So the value of B is 1, so B bar, sorry, B, C bar. And for the individual group, A is constant, B is 0, and C is 1. A, B bar, C. Okay. So I is A plus B, B plus C, A bar plus B bar plus C bar, or Y is equal to A bar B plus B C bar plus A bar C. Now the thing is that how can we verify that both are the correct or both are the same? Okay, because the question is same. Either we represent in the POS form or either we represent the SOP term, the term should be equal. So how can we verify? We can convert a POS form into the SOP and try it. So if I multiply it, so AB plus AC plus B plus BC. Okay, and multiply with A bar plus B bar plus C. So AB multiply with A bar 0. AB multiply with B bar 0. AB multiply with C bar is the A B C bar. AC multiply with A bar 0. AC multiply with B bar, so A B bar C, and AC multiply with C bar is 0. B multiply with A bar B plus B multiply with B bar 0. B multiply with C bar. That is again A bar B C. That is 0, and last one is also 0. Okay, so we are getting the A bar B, we are getting the B C bar, B bar, we are getting this one. Now two extra terms. So from this one and this one, I can take a B C bar as a common. So it is a bar plus 1. And from the this one and this one, I am taking A bar B as a common. So 1 plus A B bar C. So 1 plus A is 1. So that is B C bar plus 1 plus A is 1. So that is the A bar B plus A. Now you can check that this term and this term both are equal. That means either we solve in SOP form or we solve in the POS form, both are same. Okay. Now how we verify the how we can choose that which form we have to select. So that is all dependent on the options. Okay. If the option are given into the SOP form, so what is the way we convert that into the SOP? We solve into the SOP form. And if options are available in POS form, we solve into the POS form. Clear?
Yes, sir.
Okay. Now there is one more thing is the don't care condition. Okay, don't care condition. What is the meaning of don't care condition is that, like for example, we have a one term BC bar. Okay, that is the final output Y. Like for example, we are assuming that Y is a BC bar. So when the Y will be 1, if B is 1 and C is 0. Okay, we have a 3 variable equation. The value expression is BC bar. We are choosing when Y is the 1. So Y is the 1 when B is 1 and C is 0. Okay, but what about the third variable A? What is the condition of A?
Can be true in any case. Either it is
Any
zero
case,
or one.
either A is 0 or A is the 1. In any cases, this particularly BC bar is only dependent on B and C. That means we doesn't have any effect of this A. Okay, so we can say that we can't care about the value of A. If A is 0, no problem, or if A is 1, again no problem. Only the problem is with the B and C. Okay, so Y should be 1 only when B is 1 and C is 0. Okay, so this particular condition where any input doesn't create any effect, we call them the don't care condition. Okay, the don't care condition. We will get a more clarity when we go into the cascade circuits in the next levels. Like for example, week 6, week 7, when we go to the next particularly part where we are using the cascade condition, so where we basically understand what is the effect of this don't care condition. Okay, and why we choose this don't care condition. So in the some questions like sigma m, yeah, the representation is in the SOP form. I just represent a sigma d any term 1 3, and for the POS form we can represent as a pi d. Okay. So sigma d is the representation in SOP form and pi d is represented in the POS form. Okay. Now the thing is that we use don't care condition when any possibilities to maximize the group size. Maximize the size. Okay, like for example, if we want to maximize the group size, we can use the don't care condition. Some particularly don't care conditions where there is no effect to maximize the group size, we can't consider. Okay. So like we solve one question, we can get more clarity why ABC is sigma m 0, 1, 3, 4, 7 plus sigma b 2 and 5. A, B and so 0, 0, 0, 1, 1, 1, 1, 0, 0 and 1. 0, 1, 3, 4 and 7. And there is D. D is of 2. Okay. Now we can create a group. One group is, we can create this one. Okay. One group is, we can create this one. Okay. So we consider this group to maximize the size. Otherwise, what will be happen? We have to create a group of 2. Okay. We have to create a group of 2, and group of 2. Now what should we do? By including this D, we can create a group of 4. Okay. So we only consider the don't care condition where any possibilities to maximize the group size. So initially the group size is 2. Now by considering this D, we can create a group size of 4. Now what about this one? Okay, we can see that all 1 are covered. 1, 2, 3. All ones will be creating a group. Okay. Now there is no need to create this group. Okay. No need to create this group because this group only used to consider this D. Otherwise, all the 1, 1, 1 will be covered in a group, 2 groups. Okay, all 1 will be considered. Now, if we create this group, so this group is only for this don't care condition. So the condition is that we only consider the don't care condition where the possibilities of the group size to increase the size of group. Okay, but we can't consider the don't care condition where the number of terms will be increased. Okay, if we consider this one, in place of 2 we are getting the 3 terms. Okay, so what we do, we are removing this group. No need of this group. Any doubt?
No, sir. Sir, if taking the don't care condition increases the number of terms in the final thing, we don't use that particular don't
Yeah,
care.
if any particularly only for the mean terms are only basically don't get condition are there, and that don't get condition will increase the number of terms. We don't consider that.
Okay, sir.
Okay, that is our choice that we want to consider that as a 0 or as a 1. So if I consider as a 0, so no group will be increases. Okay,
Okay, sir.
so the group is, you can see the group of 4 is created, so A is variable, only B is constant, so B bar. And for the second group, again A is variable, only C is constant, so C is the answer. Y, A, B, C, D, sigma M 0, 1, 2, 5, 7, 8, 11, 12, 15, plus sigma D 4, 9. Zero, 1, 4, 5, 7, 6, 8, 9, 11, 12, 13, 15, 14. Not what the condition is. 4, 8, 9. If you consider this D, so we can create a group of 4. Okay, if you consider this D, so we are creating a group of 4. So this will create a group. If we consider this group, so there is a possibility that two particularly upper one and two particularly lower one will be create a group. But we can see all three ones in this group are already considered. So we are not taking this group. Is it clear? This one is considered, this one is already considered, this one is already considered. So why we create a extra group? Okay, similarly this way you can create a this group also. But this one is already considered, either the for the upper one as well as the for the lower one. So don't need to consider that. So we are not considering that one. We are not considering.
Sir, so the process should be like utilize all the ones first and see
Yes.
if you can create groups and then only go for D, the don't care conditions.
Yeah, if you see that one in this one, there is we can see that if we consider this B, so the group of four is possible.
Right.
Okay, so we consider that.
Okay. So here, like in the third column, if we
Last
take
one.
in the third column, we have the top two, and then we can also do one and D, the bottom row, one
These
and
two.
D. Yes, sir. No, the bottom
These
one
two.
and D. Yes, sir.
Yeah.
So
Yeah, you can consider that one. No issue.
okay, okay,
Okay. That is the one. So you can do with that. Create a this group and create a this group also. Then this D is considerable.
okay.
Okay.
So we'll get different answers. So then we have to check
Yeah.
what is available in the options.
Yes, exactly.
Okay. Okay.
Similarly, where you can use this third group also, D group also. So what we do, we are creating this group, we are creating this group. So this D are also considerable. But in this scenario, one, two, three ones will be considered in three different groups. So basically they created three mean terms.
Okay.
Okay.
Okay. Okay. Okay.
So
Okay.
what we do, we are using two means term. So this one is already considered. So I'm just taking this one, these two, and this last one we are taking with this. So
Okay.
two midterms.
Okay. So the whole objective is to reduce the number of terms that will.
Yeah, exactly.
Okay. Okay.
Clear? Any doubts? Now I think you can write the equation for that.
Yes.
Shall we move next?
Yes, sir.
Now, now with the came up, we have a three particularly definitions. One is the implicant, Second is the prime implicant. Third one is the essential prime implicant. And special prime. Two. Now we go with the essential prime implicant. In the gate, asking the prime and essential prime. So, like for example, we say that sigma m 1, 4, 5, 6, 7, 12, 13, 14. So, 3, 4, 1, A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0. Okay, now I represent that 1, 4, 5, 6, 7, 6, 12, 8, 9, 11, 12, 13. Okay, so we start with the implicant. Okay. So what is the meaning of implicant? Implicant is basically the terms that are available in this particularly form or in this one K-map. It is called the implicant. Okay, so how many terms are there? If we go with that, 1, 2, 3, 4, 5, 6, 7, 8. Total 8 terms are there. So what is the meaning of implicant? Is total 8. Okay. So these are called the implicant. Every individual term is called the implicant. Now we are going to create a group. So one group is this one. Okay. One group is this one. One group is this one, and one group. So there are basically 5 groups. One, two, three. Sorry, 4 groups are there. You can create a group of 4. One group is this and okay. So there is 3 group of 4 and one group of, okay. Any doubt?
No, sir.
So how many groups you can form? These are called the prime implicant. So prime implicant is 4. The term for the prime implicant is, we have to draw the expression for every term. So this is the group of 4. So it is A bar B. Group of 4. So B is constant and C is constant. So B, C bar. Okay. Group of 4. So B and D is constant. So B, D bar. And group of 2, this one. So A is constant, A bar. C is constant, C bar, and D. These are the prime implicant. Okay.
Sir, so that's the final term that we get after elimination.
Yeah.
Okay. Sir, so
Okay.
that in cases it may happen that the terms may be different, but will it be that the number of terms will remain the same? Like we may have, like in the example that we saw earlier, the actual term was different.
Yeah.
We had two terms for one
Mhm.
particular case.
Mhm.
So that
So the prime implicant is the minimum. Okay, like for example, if we go with the previous question, so we are creating a three group. One group is this one group is this one, and one group is this one. Okay,
okay. Yes, sir.
so here the number of terms are maximum higher than that we are considering. We are considering this one and this one. Okay, so what is the prime implicant? Is the minimum after group. Okay, so how many in if I am taking this example, so we are taking uh, one column group, so one prime implicant, and along with that, with this is a group of 4 we are taking, so two prime implicant, along with this one, and two groups of 2, so 4 prime implicant, and after that we are taking this one and this one, so only 5 prime implicant. Okay, and if we consider a different way, so one group is this one group is this one, or basically this one, or one group is this one. Three group, four group, five group, and the group of six. So six particularly prime implicant, but which one is the correct minimum of these two? So that is the five.
Sir, in one of the earlier ones, like we had got one single term which was different due to uh,
This one.
no, I think it was before this. About this, I think. About this. Yes, sir, this one. So here what we have is we have this particular, only the last term is different. We get different
Yeah,
terms for two this thing. Then the
but the
number
prime
of,
implicant is five.
okay,
Either we are considering this one or we are considering this one. Only we can consider one now.
right.
Okay, so the prime implicant terms is five.
Okay, so the number remains the same even if the term, particular
Change.
term is different.
Yeah.
Okay.
So in the gate
Okay.
examination, they are only asking the particularly terms. How many terms are there?
Okay, sir. Okay.
Okay. Now one is the essential prime. Now if you have created some groups, okay, in every group you have to check which is any term is available that is not create any other group.
Sorry, sir. Could you repeat?
Yeah, I just repeated that. I have to check, is there any group is available where the terms mean terms that are available that doesn't create a group with that is then that is not possible to create that group with the other one. Like for example, I'm just taking that, I am taking this one group, okay. Now in this one group this one is possible. Is it possible to create this one with the include this one with other particularly group?
No, sir. No other group is available.
No, for this one, only one group is possible, and we consider that.
Right.
Okay. Similarly, if we go with this one will be create a group of this four. Okay. Or the possibilities is that this one will be create a group of two. Or the possibilities is that this one will be create a group of two. So that means this particularly one will be create a group, three groups, different group, or that will particularly term will be combined with three groups. Clear?
Yes, sir.
If we go with this one, that will be create a this group, or that particularly will be include in this one. I just change the color. So that one will be created this group, or that will be included in this outer group. Now it's fine. So this particularly is not create a single group, that will be included in two groups, or possible is that that will be created this group, or possible that that will be created this group.
Yes, sir.
Okay. Now how many particularly groups we have formed where the particularly any terms is available that doesn't create any other, that is called the essential prime group implicate. So we have created a three group of four and one group of two. What is the terms of that one? This one. Okay.
Yes, sir.
Now we check with one first group. What is a bar b? Six, seven. Yeah, this one. Now we consider the first group. That is group is okay. Second group is BC bar, group of four. Third is BD bar. Okay. Fourth is this one. So we create a four groups. Okay. Now in this group, one term is available that is not created any other group. Okay. So this term is essential prime implicant. Now the definition of the essential prime implicant is that this term is essentially required. Okay, this term is essentially required. Why? Because this one we can't consider this one in other group. We can't consider this one in any other group. So that particularly term is required. That's why it is called the essential prime implicant. Okay. Any doubt?
So
Yes, any doubt?
we have to include the term which or the essential prime implicant is the one uh, which has a term without which can't be grouped with any other term.
Any other group.
Okay.
We have created four groups, three groups of four, and one group of two. So we have created the four groups. So these four terms we are getting. Clear?
Yes, sir.
We show this four groups here. Now can you see that this group of two, where one term is available, this one is available, that cannot create any other group.
So only one group is possible.
One group is this one. Okay, essential prime implicant. Now if we see that this is the group of four, here this one is included in this four group as well as in this two group.
Right.
Okay, this one is, it will be created this group or a this group, so that will be included in two groups. Okay, this one, that is include in a group of four this one, and a group of four this one, so that is not considerable. Now
Right.
here you can see this one, this one will be included in one group only.
Okay, sir.
Okay, this particularly will be group in one group only. So that term is the essential priming. So where this term is available, this term is available in the group of four, this row group A bar B. So that is the essential priming. Okay.
So then, where do we use all these? Like, is there an application for this? Like, for like
Basically,
we are classifying.
essential prime implicant we are using when we go to the delay part. Okay,
Okay.
there are the static hazard terms is available. Like for example, we are changing some one to zero. Okay,
Okay.
so in that scenario, it will be take some time. Gate will be having some delay because it is a combination of the either the CMOS or basically the BJT combinations. So they are taking some delay.
Okay.
Okay, because they, if you are go into the deeper part of the either BJT or CMOS, there is one capacitor will be introduced. Okay, and when the capacitor is introduced, capacitor have some charging and discharging time constant,
Right.
and because of that charging and discharging time constant, we are getting the delay. Like for example, we are applying the input at some time, so we are getting output after 2 nanosecond, 4 nanosecond, 5 nanosecond. That is practically. Okay, ideally what we consider that there is no delay,
Right.
but the capacitance is very less, but practically there is some delay. So because of that one, our transition will be done from 0 to 1 or 1 to 0. There are some hazards condition will be available. What is the
O-
hazard condition? That is no undesirable condition,
Okay.
but that will be happen because of the gate delays.
Okay.
Okay, so in that particularly scenario, this particularly prime implicant and essential prime implicant is important.
Okay. Okay. So we'll
Okay,
study these further, like in the.
actually, I think that is not covered in this particularly part, but that is important for the gate examination.
Okay. Okay. I mean, in further courses, maybe that is in design.
There is a one DSD course is there where
Right.
you discuss particularly the delays part, but
Okay.
these not implicant prime implicant you are not discussing.
Okay. Okay, sir.
Okay. Now we go to check some other groups. So this one, if we are taking this group of four, so this one will be covered in two group, this one will be covered in two group, this one will be covered in two group, but this one will be covered in one group. Okay, so this group of four also a essential prime implicant. So we say that what is the term? This is the B and this one is the D bar. So B D bar is again essential prime implicant. Okay, the remaining term is this group. So this one will be considerable, this one will be considerable, this one will be create a different group, but this one is also in a single group of four. Okay, so this one include in this group, so that is also essential prime ingredient. So that term is B C. So essential prime implicant for this example is equal to the prime implicant. Okay, so you understand what is the basically essential and what is the prime implicant. So we can solve more questions related to that one.
Okay, sir. So what we are saying is that an essential prime implicant is a prime implicant in which there is at least there is one term which can't be grouped with which has only one group, which can
Which
be grouped only with.
which only create one.
Okay. Okay. So then we can classify that particular prime implicant as an essential prime implicant. Okay, sir.
Okay. Now the example we are taking that is more clear to you. 1, 5, 6, 7, 11, 12. One, 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 11, 12, 12, 13. Okay. Now one group is this one. Group of this one. Of this one. Of this one. Okay, so first of all, the implicant. So how many terms are available? 1, 2, 3, 4, 5, 6, 7, 8. 8 terms are available. So 8. Okay. Now the prime implicant. How many prime implicant?
Five.
So basically, prime implicant is what? How minimum we can particularly make a group to cover all the mean terms. That is the prime implicant. So we required a 5 groups. Okay.
Yes.
We create 5 group basically in that one. So the implicant is 5. So the term is A bar, C bar D plus for this group that is the A, B, C bar plus for this group that is the A, C, D plus for this group this is the A bar, B, C plus for the center group this is the B. Now we go to the essential prime. So if you see that this group, this one is not created any group, any other group. So this is the prime, essential prime A bar, C bar, D. In this group, there is one. This one doesn't create any other group. A, B, C. In this group, this particularly it doesn't create any other group. A, C, D. This one doesn't. This one doesn't create any other group. So it is a bar. Now the group of four. Okay. This one already create include in this group. This one already included in this group. This one already included in this group. And this one already included in this group. So all ones are included. So that means this particularly is not a essential prime implicant. Clear?
Yes.
Okay. And final expression if we are talking about, so that is the A bar C bar D plus A B C bar plus A C D plus A bar B C, because this group of four is not required. Okay, all ones are already covered in other groups, so this particularly is not required. So this is a simplified expression. Okay. Now that I already told you that there are some particularly problem hazard conditions. So there is a static hazard 0 or hazard 1. Okay. So in this scenario, what we do, we include this term to overcome this static hazard. This is our prime implicant term. Okay, and we include this term to remove static. Okay, so essential prime implicant is basically our simplified expression. This is our simplified expression, and this is extra term to remove static. Yeah, why we require the EPI and why we require the PA. Any doubt? Yes, any doubt?
No, sir.
Now we move to the five variable thing. So F A B C. Okay. Like for example, I am taking one case is that we know that from 0 to 15 the value of A is 0, and from 16 to 31 the value of A is 1. Okay, so there are the two methods. Method is that either I create A B C D 0 0 0 1 1 1 0 0 0 0 0 1 0 1 1 0 1 0 1 1 0 1 1 1 1 0 1 1 0. Okay, so we are taking in this group in this way. Our second method is that we are treating it two particularly group of B C D B C D. For this one we consider the value of A is 0, and for this one we consider the value of A is 1. Okay, because from 0 to 15 the value of A is 0. Okay, what is the representation for 0 to 15 is 0 0 0 0 0 to 0 1 1 1 1. This is 0 to 15. And for 16 to 31, 1 0 0 0 to 1 1 1 1. So the value of A is 1 and the value of A is 0. Okay, so what we do, we created two groups. Initially the value of A is 0, and then after that the value of A is 1. So that is the 0 1 3 2 4 5 7 6 8 9 11 10 12 13 15 14. That one is 16 17 19 18 20 21 22 24 25 27 26 28 29 31 and 30. Okay, and for this one 0 1 3 2 6, 7, 5, 4, 8, 9, 11, 12, 10, 12, 13, 16, 17, 19, 18, 20, 21, 23, 22, 24, 25, 27, 26, 28, 29, 31 and 30. Okay, the answer should be same. But the in this particularly second part, there is a group. Group is very basically tricky. So how we can create a group? Either, for example, we have a group of 4 here, and basically group of 4 here. So what we do, if we overlap these particularly two matrices, so this group of 4 and this group and 4 will be overlap. Okay, so that will be create a group of 8. Okay, that will be create a group of 8. Why? Because for these 4 we have a okay, and if we overlap this group and this group, so basically this particularly group, when we are taking the two matrices, so this will be the 3 dimension. Okay, we overlap these two matrices onto each other, so that will be create a group of 3 dimension. Okay, so in the 3 dimension, what will be the advantage of that one? Our value of a is changed, so we are not consider the value of a, only the value of b and c is considered. But if any group is not overlap, like for example one group here is this one and here the group is this one, so these group are not overlap, so what we do, for this group we have the value of b, c, d, e, that is okay. Along with that we have to consider the value of a, c. Okay, and for this one we have the value of b, c, d, e. Along with that we consider the value of a is 1. Okay, so let's take an example. So we will solve with the both method. Sigma n 21, 22, 25, 27, 28, 29, 31. Okay, we have this one. So we will solve with the both method. The answer should be C. So first of all, we are representing with the in this particularly. It's here. 0, 1, 4, 5, 8, 9, 11, 14, 17, 21, 22, 25, 27, 28, 29. Okay, so we are now creating the groups. Can you check this group will be overlap with this group? No. Then we created this group. Is this group overlap with this group? No. Okay. Now we can create this group. Is this group overlap with this group? No. Okay. Let's we take a group. Okay. Now this group will be overlap with this group. So we are going to combine. Okay. So in the first matrix, all ones will be considered. Now we move to the second matrix. So here are a group of two, group of four. This group. Okay. That is not overlap with this one. Okay. This group not overlap with this one. So this is the overlapping. Okay. Now these two. So we are getting this one and this two. Now here is the option is that this one is remaining. If we consider this group, here also one group. Okay, two overlapping group. Now we can see that in the previous overlapping group we are saying that the last row, okay, 25, 27 and 9, 11. So basically if we remove this group, so any effect of that one, so I'm just going to remove this group. Okay, there is no effect. Okay, because the previous group that we consider in the last row, already all the terms are considered. Okay, all terms are considered. This one is considered in this group of 4. This one is also considered here. This one is considered in the group of column matrix, this one, column group. And this one we are considering in the group of 4. So that means no need to create a group of last row. Okay, I just mark it with this one. So that is not required. Green one. Okay, green one is not required. Why? Because all the terms are already included. Is it clear? Any doubt in that?
So we just have to ensure that we are not including anything that is already covered in any other group.
We include, yeah. If all the terms are already covered in the group, why we take it two different terms?
Oh,
Because that will be increase the number of terms, also increase the number of gates, also increase the complexity.
okay.
Okay. Now we write the expression for that. So I just mark with the name also, number also. So I just say that this is the group one. So the expression for group one is what? For the expression of group one is that B is constant 0 0 and T is constant. So B bar. But remember that for this matrix, A is also constant. A is 0. So I have to include A always. So A bar, B bar, T bar. Okay. Now the second group. This one is the second. Okay. Now for the second group, this one and this one. So C is constant 0 0, C bar, and D is also constant 0 0, so D bar. But remember that for this matrix, A is also constant, so A bar. Clear? Now we are taking this the third group. So for this group, B and C is constant 1 1, as well as D is also constant, that is also 1. But A is also constant, that is 0. Okay. Now we consider this and this group. Okay. B is constant, D is constant, E is constant, and all values are 1. As well as you can see, when we are going to overlap this one, this will be create a group of 4 where A is also not a constant, because in this group A is 0 and in this part, in this matrix, A is 1. And we overlap these two, so this will be create a group of 4. 2 in the row and 2 in the height. Okay. So A is not constant, so that's why A term is not here. Is it clear how we write the expression for this overlapping group?
Yes.
When we do some more practices, so I think better that you can solve it easily. Just wait a minute. Hello. Yes. So when the group is overlap, the constant value of A is also variable now. So that means A is 0 and A is 1. So that is variable. So we not include the A. Now we move to the second matrix because all the matrices of group 1 is covered. Okay. Now we go to the second. So this is the group 5. So for this group 5, D is constant and E is constant. D is 0, D bar, E is 1, E. But for this matrix, A is also constant. A, D bar. And the value of A is 1 now. That's why I take plus this group. B and C is constant. So B, C, as well as D is also constant, they're 0. D bar. But A is also constant, so A plus this is already covered. This is the 4, 5, 6. This one is the 7. Okay. For this one, B is constant, B bar. D and E is constant, D, E bar, as well as A is also constant, A. Okay. So 1, 2, 3, 4, 5, 6, 7. 7 terms are present. So you can see this is the essential time implicant. Okay, any doubts? Now if you go with this matrix 0, 1, 4, 5, 8, 9, 11, 14, 15, 17, 18, 21, 22, 25, 27, 28, 29. Okay, now we are going to create it. 1, 2, then we can create a group of people. So here we are going to state something. getting this one. 1, 2, 3, 4, 3, 4, 5. This one is 11, so this one 6. Zero, 1. Create a group of this one also. This and group of this is also possible. So I just remove all the groups right now. Zero, 1, 4, 5, 8, 9, 11, 14, 15, 17, 18, 21, 22, 25, 27, 28, 29, and 30. Yes, there are the group is very tricky for that one. Okay, so one group of 4 is this possible. One group of 2 and group of 2 is also possible. Then group of this 2 and group of this 2 is also possible. Basically that is again if we are folding that particularly paper from this one, from this is the center, okay, and you when you are folding, so which one is the overlapping, you can check that one. Okay, so according to this one you can create a group. Okay, so these two group is also, this combination of these two is possible. This will be created one group. This one and this one will be created one group. So better is that we can create a group of this one, 25, 17 and this one. Okay, this will be create a group. Mhm. This will be create a group. This is the a single group. This one is a single group. Okay. This one is a single group. 1, 2, 3 group of 4 created. Now one more group is there. Uh, One, two, three. Now this group. Okay, this is the individual group. This is the individual group, and this one is remaining. So this is the individual group. Okay, so in this way we can create a group. So better thing is that if you are hold from this one, okay, and just overlap these two. So which particular group will be overlap, we can use that groups, make a group, or we can use this method that is a better method as compared to this one. Okay, if we are going to solve the question, so we can take some questions. So A, B, C, D is equal to sigma m 0, 1, 3, 5, 6, 8, 11, 12, and 15 plus sigma d 2, 7, 14. A, B, C, D is equal to sigma m 0, 4, 6, 7, 9, 10, 12, 14, 15 plus sigma d 1, 3, 13. Y, A, B, C, D is equal to Y, A, B, C, D, E equal to sigma m 0, 1, 4, 5, 8, 11, 14, 15, 16, 17, 21, 22, 25, 28, 28, 30, 31. Put 27, 30. Plus sigma d 2, 6, 12, 25, 28. Okay, so these are the three questions. You can solve that one, and we will check in Wednesday class. Okay.
Okay, sir.
Okay. Thank you all. See you on Wednesday.
Thank you, sir.
Thank you, sir.